Find the vertical force Fy in newtons required to hold the plate still. In this problem, a hydraulic jet of water discharges from a circular opening which has a diameter of 15 millimeters. The jet has an initial velocity of 1.5 meters per second, and a plate is located 1.5 meters below. The problem also instructs us to neglect the mass of the plate and the mass of the water ponded upon the plate. From Newton's second law, we know the sum of the forces acting on the plate equals mass of the plate times the acceleration of the plate. And acceleration is defined as the change in velocity over the change in time. Since we're interested in finding the force when the plate is still, this means the velocity is constant, which makes dv equal to 0, and which also makes the entire right-hand side of the equation equal to 0. The sum of the forces acting on the plate include the force of the hydraulic jet, which acts downward, plus the force we're solving for, Fy, which acts upward, as well as the gravitational force of any standing water and self-weight. Since the problem states to neglect these gravitational forces, we'll remove them from the force equilibrium equation, which means our force, Fy, equals the force of the hydraulic jet. The force of the hydraulic jet equals m dot v, where m dot is the mass flow rate of the water and v is the velocity of the hydraulic jet, as seen by the plate. We'll define this velocity as v1, as opposed to velocity v0, which is the velocity of the jet 1.5 meters above the plate. The mass flow rate equals ρ times v times a. It will be easiest to determine this product by examining location 0, because we've been given v0, which equals 1.5 meters per second, and the area a0 equals pi over 4 times the diameter squared. After plugging in the diameter and after converting units, the area of the hydraulic jet at point 0 equals 1.767 times 10 to the negative 4 meters squared. The density of water in metric units is approximately 999 kilograms per meters cubed. This makes the mass flow rate equal to 0.2648 kilograms per second. Having solved for m dot, we next need to solve for v1, the velocity of the hydraulic jet as seen by the plate. From Bernoulli's equation, we'll assume there is no head loss across the 1.5 meters the water is in the air. Also, since there is negligible pressure change, we can cancel out the pressure head terms on both sides of the equation. Next, we'll solve for variable v1, which equals the square root of v0 squared plus 2g times the quantity h0 minus h1. The problem statement provides v0 as 1.5 meters per second. G is 9.81 meters per second squared. And the difference between h0 and h1 is h, which measures 1.5 meters. This makes the value of v1 equal to 5.628 meters per second. This velocity times the previously calculated mass flow rate gives us a hydraulic jet force of 1.49 kilogram meters per second squared, which means the vertical force, Fy, also equals 1.49 kilogram meters per second squared. After converting units, the vertical force, Fy, equals 1.49 newtons. When reviewing the possible solutions, the answer is A.